All right, inverse functions. I think I started this yesterday in the wrong way. So I'm going to start it the way we usually do it and see if it is less confusing, because I think some of you left yesterday confused about the graphs. I know you can do linear. I know you can solve linear equations, so I'm going to get to the harder stuff. Okay, so we're going to calculate the inverse of y equals x minus 2 squared plus 1. Get right into the algebra. What? I tried that yesterday. It didn't work very well. Exactly. We're going to go with the old standard here. Okay, the first step is to set it equal to y. If this is f of x, you just set it equal to y. All right. Next, what did you say, Logan? There's two ways you can do it. You can solve for x first, or you can swap x and y. Take your pick. Solve for x. Okay, so if we're going to solve for x, Logan said subtract 1. Okay. Was what I wrote not quite correct? Do you remember? What do we have to put in front here? Plus or minus. Yep. The square roots don't give us a negative case, so we have to account for that. Okay. And then somebody, last step. Thanks, Zach. So we get positive or negative y minus 1 plus 2 equals x. What's our last step? Well, second to last. Swap x and y. You can do those in either order. You can change those steps. It doesn't matter which one you do first. If you swap x and y first, then you're solving for y. If you want to do it that direction, it's fine. That's actually the way I usually do it. Okay. All right. So we have that's our inverse. Go ahead and graph the original equation. Using your knowledge of families of functions. Does anybody still need help with that? Families of functions stuff? Yeah. Okay, we have our base. What's our parent? What's the parent function? It's this one. Okay. What are we going to do to this one? Move it how?
Move it to the right, to the left one.
It's opposite of that, right 2 and up 1. And then there's no flipping or anything. There's no multiplied number here. So right 2, up 1. Okay. Always good to put the equation with it. This is where colors come in handy. Okay, there are so many ways to do the graph of the inverse. I'm going to show you a couple of them. Okay, the first is just graph that line or that equation with the table of values. What happens if I plug -1 in? What is -1 minus 1? Okay, can I square out a negative? Okay. That's non-real, so we're not going to worry about it. How about 0? Yeah, not real. Okay, now 1 and 2, 3 are where we're going to get some good answers. This should be 2, right? If you plug 1 in. What happens if I plug 2 in? You get positive or -1 plus 2. How many answers is that then? Yeah, you get 1 and 3. So 2, 1, and 2, 3. And then if you plug 3 in, you're going to get something just like that.
Wait, what you get that 3 times?
This?
Yeah.
Positive 1 plus 2 is 3. And then -1 plus 2 is 1. That's going to be somewhere in here. So we have our general shape now. Okay, so that's one way to do an inverse graph, is just do it. Okay, I'm going to put the other one. The second method is to reflect it over y equals x. Some people find this one harder. Some people find it easier. Y equals x. Let's graph it first.
We're going to put it in green. And I'm just going to put it on there for you to see. Okay, here's the trick with reflecting over y equals x. We know that we have 2, 1 on the original graph, right? That's the vertex of the original. Okay, that becomes the new 1, 2. Right there. That's the new vertex. What I do to my point. I switched x and y. That's all an inverse is the x's and y's are switched. That's what we did here algebraically, right? We switched x and y. That's all the graph does, is it switches the x and the y. That's reflecting over a line, y equals x. So look at these points. I know on my original, I have, give me another point on the original. 3, 2. What does that become? 2, 3. All right, you see how it's working? How about one more? Be careful here now. It becomes 2, 1. So I'm going to put this one in blue. You picked original points, now you just swapped them x and y. So I have 1, 2, 2, 3, and 2, 1. See how those are lining up? Awesome. Is that easier than I showed you yesterday? Yeah, I thought so. Yeah, that's all an inverse is just switching the x's and the y's. Algebraically, you see it. Now, graphically, you see what that means, a reflection over y equals x. Do you want me to show you what I showed you yesterday? Okay. Sounds good. Oh, let's do that. Oh, how do I put that in the graphing calculator? Make sure you have one. I'm going to show you. Okay, what's our parent graph? X minus 2 squared plus 1. Okay, put your original in. Y1. Is that easier? I actually think I have one on my computer, but this is... Okay. The tricky part here is there are two, can you do positive or negative on the calculator at the same time? No, we have to do two separate equations. All right, so I'm going to do the positive x minus 1 plus 2. No. And then I'm going to do the negative. If you have a black one, it might not. As long as you're inside the parentheses, you're going to be okay. Other calculator operations, still errors, issues? Huh? X is just below mode. It says X, T, theta, and N. I thought we got past that. Okay, go to your Zoom screen. It's that button right there. And then just go to Zoom standard number 6. There's the original, and there's the new one. Right? You don't have to put the original in.
The first question was
That's enough. Other issues?
not the same.
Oh, you have arrow over. Arrow out. Apparently not. Any other questions or issues? Alright, Zoom. Just to get the
How do you make it under all the way?
I don't even remember how to do this stuff. Arrow. After that. All right, here is the work. Is that what you wanted, Leroy? Okay. $30, $50. That's the work. So you do have about a half an hour. Right now, I want everybody to work on number 15. Try to finish it in the next 10 minutes so I can give you some feedback on it, okay?